Dear Professor, I'm JIA YONGQI with metric number 241191947. Today, I'll present my thesis titled A Study on Sentiment Analysis of Navigation Software Reviews Using Rapid Miner, the Cases of Waze and Google Maps. This presentation will cover the research background problem, research questions, objectives, data method, key findings, and conclusions. Its core focus is comparing Google Maps and Waze through Google Play reviews, aimed at building a reproducible, interpretable decision framework to help product teams turn user feedback into prioritized improvement plans. Let's start with executive summary. First, we built an end-to-end interpretable pipeline using Python for data handling and RapidMiner for modeling. Second, we used a matched review window to ensure fair comparison and reduce confounds. Finally, the outputs are practical benchmarking results, dissatisfaction drivers, and a prioritized backlog for release planning. Now, let's look at the scope and three research questions. Research question 1. What experience aspects do users focus on most for both apps? 2. How do the two apps differ in negative experience signals and their potential causes? 3. Can we build an interpretable, reproducible sentiment classification model and explain its prediction cues? Overall, this study's goal is to turn customer voices into structured, actionable evidence. To address these questions, we have four research objectives. Research Objective 1. Construct comparable datasets and extract a stable aspect taxonomy. 2. Benchmark cross-platform dissatisfaction differences with statistical significance and effect size. 3. Identify key dissatisfaction drivers and test platform-specific differences. 4. Validate the sentiment workflow and create a prioritized optimization backlog with monitoring indicators. Here I highlight what this study contributes beyond a standard sentiment analysis. First, it offers feature-level benchmarking by decomposing differences into aspect prevalence and impact gaps. Second, it provides a reproducible, interpretable analytics design, as the stakeholders need to understand model logic to act. Third, is translate text evidence into prioritization logic, answering what to fix first, why, and how to track progress. Now I'm moving to the data foundation. We collected 4,929 Google Play reviews from November 18th to December 15th, 2025, using a matched window to align sampling across apps. We applied quality controls like schema harmonization and deduplication. Dissatisfaction is defined by three metrics: low ratings 1 to 2 stars, negative text sentiment, and a joint metric where both singles agree. Now, let's talk about the decision writing method. Step 1. Process data in Python, including cleaning text, standardizing files, and deduplicating. 2. Structure reviews with a codebook style taxonomy for stability. 3. Build models in RapidMiner, including a TF-IDF sentiment classifier and logistic regression driver models with controls. We also applied false discovery rate adjustment to ensure reliable conclusions. Here are the outcome level benchmarking results. Google Maps has a higher low rating share than Waze, 39.5% versus 35.7%, a statistically significant difference. However, text negative sentiment is similar, 44.8% for Google Maps and 46% for Waze. The joint dissatisfaction gap is smaller, 36.9% versus 33.9%, and not statistically decisive. This shows rating text misalignment, so joint measurement is more credible. Now let's explore what drives dissatisfaction. For both apps, the strongest drivers are performance critical aspects. GPS and location accuracy, stability and reliability, and navigation and routing accuracy. These platform agnostic drivers are high confidence starting points for improvement, guiding tips to focus investments where they matter most. This slide covers analytics into an execution artifact. We use impact multiplied by prevalence for prioritization. For Google Maps, routing and GPS accuracy are top priorities. For Waze, routing is the largest contributor, followed by GPS accuracy and reliability. This backlog bridges evidence to roadmap, supporting release planning and measurable follow-through. This study uses linear TF-IDF-based logistic regression model for explainability. For Google Maps, it achieves strong negative class performance. Precision 0.818, recall 0.903, F 10.858, and AUC 0.934. For which performance is lower but still usable. Precision 0.776, recall 0.801, F1 0.788, and AUC 0.893. We can inspect feature widths to understand prediction cues. Note that false negatives occur in short reviews, so short text need conservative treatment, while medium and long reviews reliably inform prioritization. Let me close with the conclusions and the forward plan. First, user feedback has stable recurring aspects, supporting taxonomy-based analysis. Second, joint measurement of ratings and text improves benchmark credibility. Third, dissatisfaction is driven by actionable aspects, prioritized where impact times prevalence. For the future, expand data sources and time windows, strengthen governance, build automated monitoring dashboards, and conduct deeper root cause modeling. Thank you for listening.